that is pH, finding your pH, and pOH. So as you all know, pH simply means the degree of hydrogen ion concentration. pOH means the degree of hydroxyl ion concentration. Now please, it is important to note that pH is different compared to hydrogen ion concentration. And don't forget that pH is also that is hydroxyl ion concentration. It's still the same thing. I hope I get my point. But pH, it is not hydrogen ion concentration. It is different. pH, it is the degree of this hydrogen ion concentration. I hope you are getting my point now. So from this place now, we are going to discover, to determine a lot of formula before we arrive, because I just don't like giving out formula to students like that. I will show them how I'm able to get my formula. Now the point you have to know is that pH, I hope I get my point now, pH of a solution is the negative log of, pH is pH, so negative log of hydrogen ion concentration. That is it. pH is negative log of hydrogen ion concentration, and the natural log is always what? Into base 10. So we call this equation 1. I hope you get my point now. So for pOH now, that you all know that pOH is the degree of hydroxyl ion concentration. As pH deal with hydrogen ion concentration, pOH will deal with hydroxyl ion concentration. So from here now, pOH is the negative log 10 of OH ion. I hope you get my point now. Just like this, our pH is the negative log of hydrogen ion. This is negative log of hydroxyl ion. This is equation 2. Now from where we stopped in the last class, you will see that I told you that hydrogen ion, when that is hydrogen ion with hydroxyl ion dots here, which means that multiply on the product, we give 10 raised power minus what? 14. This is equation 3. I hope you should remember this is where we stopped in the last class. Now from here now, what we're going to do is that we will now, from here now we have said that H plus here, we have H plus here, we have OH here, pOH here. So what we're going to do now is that we are going to fix it inside 8. So from here now, we have said that H plus and OH, so equal to 10 raised power minus with hydrogen ion concentration, but it's negative inverse of it. pOH deal with hydroxyl ion concentration, but negative inverse of it. I told you that pH with pOH is going to give you this. Why? Don't forget this one is 10 raised power minus 7 times 10 raised power minus 7. 10 is common in both sides. Minus 7 plus minus 7 is going to give you minus 14. So we don't need that anyway, so we move on. So what we're going to do here is that we're going to take the log of both sides. Don't forget that the natural log of a number is base, the log will be to base 10. So we have log 10, hydrogen ion, taking the log of both sides. The log we have made this, affect this. So of hydrogen ion, so that is plus, in log, multiplication will change to addition to log 10 of hydroxyl ion. So this one to equal to log 10. This will come up 10 raised power minus 14. I hope you're getting my point now. As you know, the log of a number to its base, the log of a number to its base, that is a number having the same thing. Look at it. Log 2 to base 2 is 1. Log 3 to base 3 is 1. The log of a number to its base is always 1. So we simply mean that this will turn to 1. Then we have log 10 of hydrogen ion plus log 10 of hydroxyl ion equal to 1 times 10 raised 1 times minus 14. So which will eventually give you minus 14. So that clearly shows that we have gotten a new formula. One doesn't actually end here, so we have to continue from where we stop. So from here now, from where we stop below, so that is from this. So we have log 10 hydrogen ion plus log 10 hydroxyl ion equal to minus 14. Now, don't forget that pH equal to minus log 10 hydrogen ion. So we have to make this minus so that it will fix for pH. but you don't actually have to be afraid. You cannot be asked to be finding all this. I hope you're getting my point. But I'm just doing all this for you guys so that you can know how I'm able to get the formula. Because one thing I believe about chemistry is that chemistry is like you don't have to climb anything, but you have to know it. That's just the fact. So what we're going to do now is that we're going to multiply. So multiply both sides by -1. So when you multiply this by -1, you have minus log 10 hydrogen ion plus, so multiply this by -1, you have minus log 10 hydroxyl ion. Minus times minus will give you what? Plus 14. So this is our new formula. Now, and don't forget that minus log 10 of hydrogen ion means pH. I hope you're getting my point now. Why minus log 10 of hydroxyl means was POH. So we put plus POH equal to 14. So this is another new formula that we've got in. So in summary, we simply means that from here now we can find our pH. We simply means that pH equal to POH minus 14. We simply means that that is 14 minus POH, or POH equal to 14 minus pH. So I hope you guys have got example 1. So to verify how to calculate pH and pH. Now you have to calculate the pH of an 0.01 molar of hydrogen nitrate 5. Now the important thing that you have to know is that you have to find the pH. The question you have to ask yourself is that HNO3, is it an acid or base? It's an acid. So according to neutralization process, neutralization can be divided as a process by which hydrogen ion from acid reacts with hydroxyl from alkali or base. I hope you're getting my point. So which means that for acid has to do with what? Hydrogen ion. Now don't forget that I told you that pH is different from hydrogen ion concentration. pH is not the same thing with hydrogen ion concentration. Now I told you that from the word hydrogen ion concentration, which simply means that the value of hydrogen ion concentration or hydroxyl must be in mole per dm cube or molar, which is still the same thing. So from here now, calculate the pH of an 0.01 molar of HNO3, which simply means that HNO3 owns this concentration and is an acid, which means that the concentration is hydrogen ion, not hydroxyl ion. Note, pH cannot have molar, but only hydrogen ion concentration or hydroxyl ion concentration will have molar, and it can only be determined by the compound given. This compound is an acid, which means that it must possess hydrogen ion concentration. So for HNO3 now, so the best thing is that you dissociate it. So HNO3. So when you dissociate HNO3, you are going to have hydrogen plus NO3 that is NO3 minus right now. So for me now, this is hydrogen ion, which means that it's just one. So you are free to go. So for hydrogen ion, as you have seen it, hydrogen ion equal to 0.001. Now it is important that you convert to index so that, especially for jamb, you'll be able to solve it without using calculator. For this now, it is 10 raised power 123 raised power minus 3. So now then you apply the formula pH equal to minus log 10 hydrogen ion. So from here now, we have pH equal to minus log 10 bracket open 10 raised power minus 3. So I hope you're getting my point now. I told you that the log of a number to its base is what? It is 1. So that's that log 10 base 10 will be cancelled out. It is 1. Then we have pH equal to minus times minus 3. Then pH of the solution equal to 3, which is simple. So in this type of question too, if you ask to find the pH, don't forget, it's very simple. To find the pH from the expression that pH plus POH equal to what? 14. Then that's that POH equal to 14 minus pH. Now, so POH equal to 14 minus, what is our pH? 3. Although this is not part of the equation, I'm just telling you if you're asked to find the pH So this is going to give you 3. Then POH equal to 11, which means that the POH of hydrogen 295 is 11. So of course, which can be proved. As you can see, it is a strong acid. So the pH has to fall here between 0 and 3. So it has to fall here. So if you are to take it according to POH in POH meter. Now let me quickly try to break that for you guys to know the difference between pH meter. In pH meter graduated from 0 to 14. So it started with acid. Acid are the strongest. So N at base. So in between is 7. But in POH meter, it started with base. So which means I started with base, here 7, N at acid. So like I said, that the POH now of hydrogen 295 that we just calculated, it is 11, which means that it falls at what? At acidic medium, which is correct. Now look at the pH of it. pH is 3, which means that it falls at acidic medium, which is still correct. pH is 11, fall at acidic medium, which is still correct. pH is 3, fall at acidic medium, which is still what? Correct. So the topic is not hard. So we are still going to take another example more. Hydrogen ion constitution in a solution is 5 times 10 power minus 3. Determine the pH. This is very simple work. So you don't have any problem here. You are told that the hydrogen ion concentration is 5 times 10 power minus 3 mole per dmq. So of course, now to find the pH, don't forget that pH equal to minus log 10 of your hydrogen ion concentration. Then pH equal to minus log 10 of 5 times 10 raised power minus 3. So you can actually split it. Don't forget that multiplication in indices, it means addition. So we have pH equal to, that is minus bracket open log 10 5 plus log 10 raised power 10 raised power minus 3. Okay, getting that logic here. So this 10 for this, so minus we change, multiplication we change to addition. Why? So log 10 we take it for this. Don't forget, log of the number 2 is this, is 1. So 1 times minus 2, you get minus 3. Then you have pH equal to minus log 10. So in your calculator, you just press log, so log 10, which is still log 5. Then you will have 0.698. That will be 0.6999. So plus, don't forget that this one is minus 3. So from here we have pH equal to minus bracket open. So the answer that you have gotten, so the answer is minus 3. So you will have minus 2.3010. Then you have pH equal to 2.3010. So I hope that is clear to you guys. So now we are asked to find out what is the hydrogen ion, pH and pOH of corresponding 0.02 molar of sodium hydroxide. Now solution, very simple. So what you are just going to do is very simple as quick. So very simple here. Now don't forget that this is sodium hydroxide. So this 0.02 molar, don't forget that because it is sodium hydroxide, so it is hydroxyl. Why? Because this is base, so its concentration must be what? In hydroxyl. So we have to find the hydrogen ion. So to find the hydrogen ion, you know that we have the hydroxyl already. Now to satisfy this, hydroxyl ion is equal to 0.02, so which is also the same thing as 2 times 10 raised power minus 2. So I hope this is clear to you. So we have found this out. So we make hydrogen ion. To find hydrogen ion, we make use of hydrogen ion plus weight, that is times hydroxyl equal to 10 raised power minus what? 14. Don't forget this formula. Then we have that is hydrogen ion is what we are looking for. Hydrogen ion equal to 10 raised power minus 14 over hydroxyl ion. So hydrogen ion so equal to 10 raised power minus 14 over hydroxy. What is our hydroxy? We have 2 times 10 raised power minus what? Minus 2. So hydrogen ion equal to, so we have 10, that's exponential, minus 14. So divided by 2 exponential minus 2. We have 5 times 10 raised power minus 12 molar. So the next thing now is to find the pH. Of course, we can find the pH because we have the hydrogen ion. We can find the pOH because we have the hydrogen ion. We have found the OH, this is this. So we have found the hydrogen ion concentration, which is this. So we can find the pH. To find the pH, we can use pH equal to minus log 10 of hydrogen ion, or I can find my pH using pH plus pOH equal to 14. So, but for me to use this, I will have to find my pH. Let me make use of this because this is too simple. So for pOH, then we say our pOH equal to, that is negative log of OH. So with this, so 10. So then we have pOH equal to minus, so log 10 of what? What's our OH? 2 times 10 raised power minus 2. So at the end of the day, we have pOH equal to minus log 10 2 plus log 10 raised power minus 10 raised power minus 2. So at the end of the day, we have pOH equal to minus, so log 2 we actually gives, that's log 2, we give 0.30, that is minus 2. Then we have pOH equal to minus 2, so that is minus bracket open 1.6989, so which is approximately 1.7. So then pOH equal to 1.7. So from here now we can just put this into this formula. So here, so now that we have gotten our pOH, don't forget that pH plus pOH equal to 14. Then if our pH equal to, so we are finding pH equal to 14 minus pOH. Then that shows that our pH equal to 14 minus 1.7. So which is equal to 14 minus 1.7. So which is equal to 12.3. So which is perfectly correct. Sodium hydroxide in pH scale is far, while sodium hydroxide in hydroxyl scale, that is a pOH scale, it is 2, which is nearer. So